Everything you have ever been told about dinosaurs is set in heat, in the scorching, humid, suffocating heat of tropical jungles and vast river deltas, in landscapes dripping with moisture and thick with dense vegetation. The dinosaur of the popular imagination lives in warmth. It has always lived in warmth because it was a reptile, and reptiles are cold-blooded. And cold-blooded animals cannot survive in cold climates. This is what most people believe. This is what most people were taught. And this is wrong. The evidence correcting it has been sitting in the rock of the Arctic Circle for millions of years, waiting for scientists brave enough to look. Because dinosaurs did not just live in the tropics. They did not just tolerate the occasional cool season at the edges of their range. Some of the most successful, most adaptable creatures in history lived permanently in environments that plunged into months of complete polar darkness every year. They were not passing through. They were not seasonal migrants making brief summer visits. They were residents. The Arctic was their home. The story of how they survived there is one of the most astonishing stories that paleontology has ever uncovered. In the early 1960s, a geologist working in the remote Colville River region of northern Alaska found something in the rock he was not looking for. He found dinosaur bones. Not a single fragment. He found bones. Multiple bones, clearly in place dating to the Cretaceous period. The find was noted with minimum fanfare and set aside for 2 decades, because the implications were outside the accepted understanding of dinosaur biology. It was not until the 1980s that a sustained program of paleontological fieldwork began in the Alaskan Arctic, driven by a small group of researchers. What they found exceeded everything anticipated. The Alaskan Arctic was home to a complete, fully functioning, extraordinarily diverse dinosaur ecosystem. Predators and prey, large and small, herbivores and carnivores, at every level of a food chain every bit as complex as those in lower latitudes. This was a world sitting above the Arctic Circle, enduring conditions that conventional understanding insisted were impossible for them to survive. How? Before we can answer that, we need to understand what the Arctic of 70 to 80 million years ago actually was. The Cretaceous Arctic was warmer than today. Greenhouse conditions pushed warmth into the polar regions, creating a climate like the Pacific Northwest. There were forests. Fossil evidence includes abundant plant material, wood, leaves, pollen, indicating a region covered in mixed conifers and deciduous trees. But it still meant months of continuous summer daylight followed by months of continuous winter darkness. The warmth changed the temperature, not the light. Every winter, the Arctic dinosaurs faced the same months of total polar darkness that plunged the modern Arctic into its winter silence. Finding food, maintaining body temperature, and raising young through that darkness shaped these dinosaurs into something unlike any other population on Earth. And in that world, predators. Not small or cautious survivors, but large, fast hunters with a sophistication driven by the darkness and the cold. In Part 2, we meet the hunters of the Arctic Cretaceous and understand what the dinosaurs that stayed became because of it. To understand what kind of predator the Arctic produced, you first have to understand what the Arctic demanded. Because evolution does not work in the abstract, does not produce innovations for their own sake, does not gift animals with capabilities they do not need. Every adaptation is an answer to a question that the environment is asking. And the Arctic was asking questions of extraordinary difficulty. It was asking how to hunt in darkness, how to maintain the energy required for active predation through months of cold and food scarcity, how to be fast enough and intelligent enough to catch prey that was itself under the same evolutionary pressure to survive. And the predator that the Alaskan Arctic produced as its answer, the apex carnivore of the Cretaceous North American Arctic, was a tyrannosaur. Not Tyrannosaurus rex, the famous giant whose image has dominated popular representations of dinosaur predation for over a century. Something different. The Arctic had taken the tyrannosaur body plan and modified, refined, and pushed it in directions that the lowland tyrannosaurs never needed to go. It was called Nanuqsaurus hoaglundi, Nanuqsaurus, from the Inupiaq word for polar bear, a name chosen carefully by the scientists who described it. Just as the polar bear is not simply a brown bear that wandered north, Nanuqsaurus was not simply a tyrannosaur that happened to end up there. Nanuqsaurus was significantly smaller, with a body mass estimated at roughly 1,000 kilograms compared to the 9 tons of a Tyrannosaurus rex. In the Arctic, where food was seasonal, being smaller was an advantage. A smaller body required less food and could be kept warm more efficiently. It could move faster through the dense polar forest, pursuing prey through the tangled understory with an agility a 9-ton giant could never match. But Nanuqsaurus was not alone. To understand the full complexity of the North, we need to go smaller, to the middle of the food chain. The troodontids were fast-moving predators with large brains, forward-facing eyes for binocular vision, and hands capable of remarkable manipulation. The Arctic troodontids had dramatically, almost absurdly large eyes, an evolutionary response to the months of polar darkness during which they needed to hunt. The Arctic troodontids were, in effect, the owls of the Cretaceous North, nocturnal hunters operating with confidence in conditions of near-total darkness. They were densely feathered, their plumage serving as a winter coat, trapping body heat to maintain the high-energy lifestyle of an active predator. No predator exists in isolation. The sophistication of a predator is always a function of the prey it pursues. The herbivore community was dominated by Edmontosaurus, a massive, herd-living, duck-billed dinosaur reaching lengths of 12 meters. It was a highly social animal, living in organized groups with collective vigilance against predators and coordinated movement through the landscape. It was the hadrosaur herds that fed Nanuqsaurus. It was the smaller herbivores that sustained the troodontids through the winter darkness. Nanuqsaurus, reshaped by the Arctic into something faster and more efficient. The troodontids hunting through months of polar darkness. What does it mean for everything we thought we knew about dinosaur biology that they not only lived at the top of the world, but thrived there? And what happened in the end to the last of the Arctic dinosaurs, the final survivors of a world beginning its slow transformation into frozen wilderness? There is a principle in evolutionary biology that is so well established, so thoroughly documented across so many different animal groups, and so many different extreme environments, that it has the status not merely of a theory, but of a law. The law that says that isolated populations in extreme environments do not simply endure those environments. They are transformed by them. The Arctic does not merely test the animals that live within it. It reaches into their biology, into their behavior, into the very architecture of their bodies and their brains, and it rebuilds them, slowly, generation by generation, with the patience of geological time and the precision of a process that has no goal except survival. And the dinosaurs of the Cretaceous Arctic were not exempt from this law. They were subject to it in the most complete way. The Arctic was the most extreme environment that any dinosaur population ever inhabited, and the most extreme environments produce the most extreme transformations. What the Arctic did to the dinosaurs that stayed, the changes it drove in their physiology and neurology, amounted to something truly remarkable. The first and most fundamental transformation was metabolic. The dinosaurs that survived the Arctic winter were not surviving like modern cold-blooded reptiles. They were surviving the way a modern Arctic mammal or bird survives, by generating heat internally, by maintaining a core body temperature. This was endothermy, warm-bloodedness, and the evidence for it is written directly into the microstructure of their bones. The Arctic dinosaurs were not reptiles in any meaningful physiological sense. They were, in the way that matters most, far closer to birds. The second transformation was neurological, the most profound change of all. Hunting in darkness requires more than large eyes. The troodontids of the Arctic had evolved eyes that were extraordinary. But light gathering is only the input side of the equation. Processing that information required a brain. not a large brain in the absolute sense, but a large brain relative to body size. The Arctic was a cognitive crucible. It selected for the ability to think, to plan, to remember, to solve novel problems in real time. And then, 66 million years ago, the asteroid came. The same asteroid that ended the age of the dinosaurs everywhere else. The impact winter would have been indistinguishable from the polar night, except that it did not end. The light did not return. The last Nanuqsaurus died in that darkness. The last hadrosaur herd died in it. The Arctic became quiet in a way it had never been before. But here is what the extinction did not erase. It did not erase the evidence preserved in the permafrost of northern Alaska. It tells us that life is more resilient, more adaptable, more biologically creative than any fixed model of what is possible can contain. Life does not merely endure its environment. It learns from it. It is improved by it. The frozen rock has been teaching it to us ever since.